So let's talk about chemical bonds a little bit. A chemical bond is formed because the energy is lowered when those two atoms come together. And it has to do with interactions between charged particles. As the atoms approach each other, we've got complex interactions going on. The electrons repel each other, the nuclei repel each other, but the nucleus of one atom is attracted to the electrons of the other, and vice versa. And so we've got this kind of balance of power thing that has to happen. A bond will form if those interactions result in a net reduction in energy. Then a bond will form. If it doesn't lower the energy, they're not going to stick together. So ionic bonds, we've mentioned these before. Ionic bonds are a transfer of electrons. So metals have low ionization energies. It's easy to remove an electron from them. They form cations. Nonmetals have negative electron affinities. When you put an electron on them, they release energy. They form anions. So the metal transfers electrons to the nonmetal, and then we have opposite charged particles that are attracted to each other. So this table summarizes different types of interactions. A metal with a nonmetal is going to be an ionic bond. We've got electrons transferred. And we learned to predict that it would form ionic compounds when we learned how to name them. If we've got two nonmetals, we're going to have covalent bonds. In a covalent bond, we have electrons being shared. So covalent means sharing valence electrons. Metal and a metal, so this would be like an alloy. Those are metallic bonds, and in a metallic bond, the electrons are pooled. They're not really shared. It's kind of complicated. So in a covalent bond, we've got sharing of electrons. They're only going to share certain electrons, but the shared electrons are going to interact with both of the nuclei. So the most stable arrangement is this, where you have the shared electron between the two nuclei, and so both of them are attracted to this electron. If the electron's over here or over here, the attraction between the nuclei with that electron is not as great. So this is the lowest energy, and then we've got that negative electron. It's basically holding the two positive nuclei together. So metallic bonding is between metal atoms. Metals lose electrons easily, forming cations, but two cations aren't going to attract each other very much. They're going to repel each other. So how does this even work? The simplest model is called the electron C model. So you think of all the atoms, all the metal atoms are going to pool their valence electrons. So like if you think about sodium. Okay, well, sodium has one valence electron. So each atom is going to contribute one valence electron to the pool, right? Those electrons then are delocalized over the entire metal. They're available to just swim around, and the positive nuclei are attracted to this negative sea of electrons, and that's what holds them together. What? I don't have a picture of that? That's just messed up. Let's make a picture. So we could think of it this way. Here's the sodium nuclei, and they've each sent out one electron into the pool. And then, I don't know, we'll make the electrons green. So we've got electrons kind of swimming around. They're free to move. Oh, one more. These electrons are not attached to a particular atom. They're free to move around. And this explains why metals conduct electricity, because these electrons can move. I think of this as a neighborhood, and each of these houses has sent a little boy out to play. And the little boys roam the neighborhood. And because everybody has a kid out there, then all the moms are kind of looking out for everybody. It's not like that anymore, but that's how it was when I was growing up. Do you like that one?
Yeah.
Yeah.